Hi guys, there might be a slight delay. I told it to put none, but I can't promise that there aren't any delays. Let me turn the volume off on this. Alright, good morning guys. If you can hear me, somebody say yes in the chat. Make sure my mic is on. Alright, so you see I'm going infinite in my screen here, so I'm going to check back on chat periodically. But what we're going to do is talk about the project today, as well as continuous probability distributions. I found what I need. Oh, good, you can hear me. Very good. Alright, so that's not where I want to go. I want to go to this one. So what I want to do, since you guys aren't going to get a chance to talk to me about your data sets individually, if you have your own data set, you're more than welcome to use it. I'll help you as much as I can through the internet. But if you want to go ahead and do kind of a group project, let's study the coronavirus. So the data I've been using, go ahead, I want the Eastern European, there we go, the European Center of Disease Prevention and Control. The reason I want you to go here is because you can get the most recent updated data. And let's go ahead and look at it. I'm going to do some analysis on it. So we'll go to data. And I'll post this link in the description of the video. Alright, so we want to download today's data. And here we go. Alright, so we have it now in an Excel file. And if we have to, we can go over this again. But I gave you a list of questions. We may refer to them. But let's just go ahead and look at what data we have. So I'm going to enable editing. Alright, so we have the date reported, the date written in month, day, year, the number of cases reported. And notice this is in reverse order. This is today. So we really can't trust today because it's not finished yet. And there might be a slight delay in how many people have it versus when they record it. We also have the deaths, the country, and the population. So we have plenty of information to analyze here. We can discretize one of the measures or treat them as discrete. For example, deaths is a finite count. We could say low deaths, no deaths, and high deaths. But we'll be creative with that. I'm not going to stick hard fast to the project we outlined before. Notice we also have the population. But now this is kind of redundant. It's the same information coded 3 different ways. Alright, so the first thing I'm going to do is get my data in order. If you click it on the column A and then drag it this way, it will sort by column A. So we'll go to data and tell it to sort it directly. So now we know the first day that these records were taken is last year, the last day of the year, December 31st. Now, we would rather have a timeline, so we're going to create a timeline here. Timeline. I'm not saying you have to do this because I asked you to find means and stuff like that, but we will eventually have to learn time series when we do regression. So let's analyze it to the best of your ability. Alright? And so let me create my timeline and then I'll show you how to do some summary statistics. So we want the date as it's defined by year, comma, month and day, minus the date that we've set as our 0 point, which is going to be 2019, 12/31. So this first entry should be 0. Alright, very good. In fact, the first set of entries will be 0 because they're for different countries. Alright, so let's see, there was something else we also would like to consider. We could consider the cases per day, but as you see, there's a lot of days with zeros. And we might also want to consider the cumulative account. But let's go ahead and summarize the totals by country. So I'm going to take my GeoID. I'm going to drop it in a second worksheet just by pasting it there. But I want to remove all the duplicates. So I'm going to pick up this column. You could sit there and sort through them and figure out what is there, but this is the easiest way to do it. Remove duplicates. So we have 203 countries. Believe it or not, yesterday there was 200 and the day before there was 198. So 4 more countries, or 5 more countries have been included in this list over the past couple days. So one thing I'm going to do is look at the data. Ow, I just hit my knee. I'm going to look at the data over time. Alright, so now that we have this, I want it to sum the case counts if it belongs to this country. So let's do that. This will equal sum if. We want it to look at this column right here for what it's looking to count. To sum. If that, what it looks at is the same as this country. Oh, I didn't put my comma. Alright, so we want it to look here, comma. If it sees what's in this column, then we want it to sum the cases that it sees here. So this is exactly what I need you to do. I'm showing you, and if I need to, I'll show you again. So there was 166 cases that were reported in Afghanistan. Alright, so I always want it to look at, well, this actually can just be copied and pasted down. So let's see. Alright, so here's our cases. Now it's a formula, so if we want to sort this, we might want to copy and paste just the values. So that's what I'm going to do. Control up, and I'm actually going to gather a little bit more information. So this is cases by country. I also would like deaths by country. Alright, and maybe even population, because that'll give us a lot of information that we can play with. Population. I'll check chat in a minute. If you have any questions, please post them. And if I don't get to them in this video, I will be teaching the same topic at 11 today. And of course, I will answer any questions via Canvas that you have. Alright, so I'm going to copy and paste this over and edit it. If I can get a hold of it. There we go. I dropped it the wrong way. Alright, so the reason it's counting 0 is because I didn't tell it to look in the right place. I want it still to look at H. If you go back over here, it moved over to I, and that's a slightly different coding system. So I still want it to look at H. And I don't want it to look at B, I want it to look at A. So I could have retyped this code, but recycling code is normally easier. And I do want it to sum F because when it moved over one, it went from E to F, and I do want it to sum deaths now. Alright. Drop this one down. And population. Well, the population is going to be the same for all of the entries because it's only in 2018 that they recorded the population for. So I could try to look up one of them. What I'm going to do is just tell it to average if I can spell average if. Again, I want it to look in that column H. And if it sees what is in column A here, I want it to average the population, which is in J. Alright. So that's the population in Afghanistan. We should be able to verify that if you so choose. So we're going to double click this down. And now we have a profound amount of information. There's actually more information that can be computed. We have the incident rate, because to say 166 people have the condition and 584 have the condition, that's really relative to the size of the population. So let's go ahead and do incident rate. How many people in a country got affected out of the total population? And so notice I'm going to have the answers to part of your quiz question because I'm going to post a data set to a specific time. I want you to use that data set so it's consistent. If you want to upload and update your data regularly, that's fine, but then you'll need to submit it as a project and not do you'll have to get with me and make sure I understand it's not the same data set. Alright, so incident rate would be the cases observed divided by the population. Kind of would like that as a as a percentage. So I'm going to go home and put it as a percentage. Alright, now I'm going to show more decimals than that because it's such a tiny number. Okay, so very, very few people, or percentage-wise, of that country passed away. Got the disease. Well, it's a virus. Alright, so our death rate. Our death rate is going to be the number of deaths equals divided by the total number of cases observed in that country. Alright, so this country had a 2% death rate. Of the people who had the virus, approximately 2.4% passed away from it. So what we're going to do, let me show more decimals. We'll drop this down. And we'll try to drop it down. There we go. Alright, so wow, look at this country. 23% incident rate. Granted, they're a really small country. So you have to be able to keep this in perspective. When there's that small of a country, there's probably a social network that's close together. Unlike China right below it, where there's 1 million people, but they're probably a little bit further separated than this one little tiny community. Alright, I'm going to copy this because right now a lot of it's formulas and I want to sort and not worry about messing up my formulas. So I'm going to copy it, drop it into a second worksheet, and I'll check on chat and make sure you guys can still hear me. So I'm going to paste just the values. And let me know if you have trouble doing any of this. Let me check chat. How many people are with us? Hey, we have 17 people. Hi, guys. Thank you for signing in. Yeah, you can't see me. You should be able to see my screen. You can see, yeah, you can see my screen. I don't have a webcam set up right now, so you get to hear my voice and see what I'm doing. All right, let's go back to, oh, that's our code. We'll deal with that in a second. We're doing analysis. All right, so now that I have this in its uncoded form, I'm going to tell this again. I really did want to keep the format of percentages, and I would like to show some decimals. All right, let's see what happens when we do this. I'm going to sort by cases. So data, sort in, from high to low. Yes, I do want it to expand to everything or it'll unconnect the data. So the most cases have been recorded in the United States as of today. We have overpassed quite a few of the other countries in terms of incidence. So now let's do this in terms of death. As you see, it's not going to be the same. Italy has a lot more deaths than we do. So let's sort it this way. Yes, we do want it to expand everything. If you only sort the column you have selected, everything else stays the same and your data is no longer in tuplets. So Italy, and so China is actually has it well under control. They're, in terms of deaths, they're now ranked 5th. We don't really need to do population unless you're interested in that. Let's do incident rates. So if we sort the data by incident rate, yes, expand it. Okay, so we have 3 countries where the population was not given. So I'm going to go and clear those out because I don't want to keep showing that I'm dividing by 0. And they have no deaths, and they have very few cases. So them being at the top is really just unclean data, not that they're the highs. So if I clear this out, and then try that again, we wanted to sort for incident rates. Yes, expand. So we have one group of here. Yeah, this group, they're a relatively small population, but once they got the condition, it looks like a lot of people got the condition. 1/4 almost of their people have been infected with this virus. And then the next incident rate is quite small, but the population also jumped. So this population right here in Somalia, I believe that is, no, VA, is really small, but they have only had 6 cases, none of which have died. All right, let's look at, where's our, let us sort it by population, just to see what the data shows us. And so what I'll do is a little bit of this each week. If you have questions or concerns on the questions I posted, just let me know and I'll address them. So China right now has a 4% death rate. 0.01 of their people have been infected with it. Alright, so let's look at death rate. Sorry for the ping. Wow, so China and the United States are not on here as the top 5. So it probably makes sense that these are a lot of third world countries or countries that just recently started observing the virus. Alright, so any questions on this? I can come back to it at the end of the video. But let's go to today's topic, which is a little bit of what we had hoped to cover Monday. Alright, I'm checking chat. Sorry for the delay. But we can not see. Can you see now? Alright, I gotta make sure you guys are seeing this, or not a good way to do this. So I have 15 of you watching now. And remember, I am doing the same topics again at 11. Alright, talk to me, guys. I know we're on a delay. I'll check back with this. Alright, so let's talk about probability in the normal probability distribution. Alright, I have a few. We see your screen, and you can hear me. So, that's the way we're going to run it right now. Man, let me see if I can... I'll try to check the delay. I thought I turned it off. Let me see. I'll work on the delay. Sorry for the delay. I just got to work it out. Post questions also. I'm going to post a discussion board for you guys. And that way you can post questions on Canvas. And that way we can address the questions without worrying about chat. But do chat to show me you're here today. Alright, so let us talk about probability distributions. I found a few apps that are going to help me do this. So the first one, we don't need to talk about probabilities in general, but I will go over that again if you wish on Monday. So we want to talk about the normal probability distribution. Alright. So this is the normal probability distribution. It is bell-shaped and symmetric. And what we mean by bell-shaped is that it has the curvature such that the mode is the most frequent observed value. It happens also to be the mean. And because of the symmetry, it is also the median. So it's very well defined, as you see by this gross monstrosity of an equation. I'm not going to test you on the equation. What I'm going to test you on is the use of this probability distribution, which we're going to cover once we discuss its properties. Another property that it has, you turn these properties off, is that the point of inflection is where the cupping of the function changes from cupping down to cupping upward, also called concavity in calculus. So since it's so well defined, the probabilities are very precise, and then we put them in a chart and they lose a little bit of accuracy. So if we were to increase this to 1 deviation, we can measure that the probability within 1 deviation is 68.27%. A lot of times we say that's approximately 68% within 1 deviation of the mean. If we were to go 2 deviations, then 95% of the data should fall between those two values. Because if we're aiming towards the mean, the majority of the data should be close to the mean. And if we go within 3 deviations, then 99.7% of the data falls. So when we're measuring the probability using a normal probability distribution, which is a continuous function, we're going to measure the probability by the area under the curve. So let's look at that. Likelihood of occurrence. So here I've set the expectation to be 100, or the mean, the deviation to be 15, and I want to know, let's say, what is the probability that it's less than 115. Then we can standardize it to use one chart, and we'll talk about that more. I think we talked about it in class before we switched modes. Then that would be 1 deviation below the mean. And remember, we were just talking, let me take a picture of this. Where's my camera? There we go. I have my stylus ready. Alright, so if we look at this, the function is so well defined that we said, here's my pen. That's a lousy line. Let me erase that. I need to turn my pen tablet. Okay. So here's the mean. That's an eraser. Here's the mean. We said within one deviation, 68% falls, approximately. So from here, from the center to this one deviation, should be 34%. And also by symmetry, we said from here back should be 50%. And therefore we should have 86%, sorry, that's a 4, 84%. And so if we can standardize this, we can create one chart so that you don't have to deal with the monstrosity of a formula. So let's clean this up and redraw it pretty. Let me go over that again. So actually let's make a different example. Because remember, one is not a lesson, one is an introduction. So if we go back to our app, 2 deviations would be 130. Alright, so let's see if we agree with the calculation from this gross monstrosity of a formula. We'll take another picture. Alright. So, according to the rule we were talking about before, within 2 deviations, and I'll show you how to use the chart right now, we're just talking about the probability distribution, was 95%. Half of that would be 47.5%. We know that this is approximately, well, this is 50%. This is the approximated value. So from here back should be a total of about 97.5, exactly 97.72. So let's talk about how we standardize this. Actually, let me go ahead and go through the lecture notes, and because I'm pretty sure we covered that before we switched gears. So let's go back to the app. Alright, so if I wanted the values between two data values, then I would just turn on both of them and say, what is the likelihood that you're between these two values? The reason it's not showing anything is because right now it's from 130 to 130. And lines don't have area. So this is why we always use a chart to the left, because we can find small differences. If we estimated this, we would go a little bit to the left and a little bit to the right and estimate a tiny probability. Alright, but let's make them separate. So let's say between 1 and an arbitrary deviation, so let's say 140. Alright, so that is pretty far away. I don't think it's showing in my graphic. Let's move it closer. Let's say 110. That's 100 to 123. Alright, that graphic for some reason is not working, but notice it does give the probability. So when you're given a z-chart, I'm going to have to take a picture before I can draw on this. Okay, so when you're given a z-score, I'll draw it on the picture. We are given that the center is 100, that it deviated 15, and we wanted to go from 110 to 123. So to standardize this, we take your data. It's a lousy X. We're going to take your data, move it off center, and reduce the variance to 1. And that will be a standard score that we can look up on a chart. So we will have, for the first one here, Z1, I'll cross it so it doesn't look like a 2, will equal 123 minus 100 over 15, which is going to be 1.553. So the way you look this up on the chart will be such that the first two, the units and the tens digit, will be given in the row. I'm also going to show you how to use technology. The test is going to be online, and therefore you will be allowed to. I encourage you to use the technology. My stylus is not working the way I wanted it to. Let me clean that up. It's because I have the keyboard and the stylus on the same spot. Alright, so we have 1.5 will be in the row, and 0.03 will be in the column. If you add these two together, they will be our z-score. And then if you look in the chart, it will give you the probability. And then you can have the probability to the left of this value. And then what we'll do is we'll do the second z-score. I'll need to pull up the chart to show you the exact values. So the second z-score, z2, will equal the 110 minus 100, which is 10, over 15. 10 over 15 is 2/3, 0.67. And so this graph that shows our data between 110 and 126 is the same as the standard normal distribution between 0.67 and 1.8. And then once we have this value, where's my pen? There it is. What we're looking for would be the difference between them. Now, if you have the graphing calculator, it's a lot easier to compute this. It's also easy to compute this in Excel as well as in R. So let's look at Excel. So I'm going to go ahead and just grab another worksheet here. Equals normal cumulative. So I'm going to say normal dot distribution. And it'll tell you what it's doing. It returns the normal distribution for a specific value. So dot distribution. We wanted to have, well, we're going to have to do them one at a time. This will give us to the left. So we had the original value was, let me double check it again, 110 to 123. So we want to go behind 123, given that the mean was 100 and the deviation was 15, and we do want this to be cumulative. Then we can find the probability to the left of the other value. It is also normal distribution. This time we wanted 110 with a mean of 100 and a deviation of 15. Yeah, I know, I forgot a parenthesis. Oh, I forgot to tell it I want it cumulative. So if we look at the difference between these two values, that would be, oh, I see, I accidentally went down to A3. I want A1 minus A2. So there's an 18.98 or approximately 19% chance that the data is between 110 and 123, given that the mean was 100 and the deviation was 15. Again, this is what our second example. Remember, it may not click until we do 4 to 5. I'm willing to do more. You just need to let me know that you need it. Alright, let me go ahead and pull up my second app. Actually, I was doing research on my other R. I don't think we need anything more here. Let's look at what I have available. Critical values we'll cover later, and the charts right now in this app is not working. Let's close this app and run the other app. So this app is going to show you how to visualize the chart. If I can post these apps for you, I will. Oh no, that's discrete. So when we get into normal approximation, we want this app right now. Alright, if you haven't said hi to me in chat, please do so. Oh, I gotta stop the other one. Okay, here we go. I think I just restarted my app. My software. Alright, so let's run this app. Alright, so this is our normal probability distribution. Now this is kind of what I'd like to be able to get you to use, because not only does it visualize it for you, it gives you the answer. Notice it's very similar to what we had before. Let's put the same answer in. If we had a lower bound of 110 and an upper bound of 123 and a mean of 100 and a deviation of 15, then the probability would be the same as what we had before. Let's look at our Excel file. Yep, rounded to 4 decimal places. And so what's nice about this app is it can also show you how to break it down in terms of a chart. So when you look at, let's set these to the same values we had in the other example. 23. Alright, so this is how you would have to do it. My graphs are a little skewed here because of the size is so small, but we can adjust that. Let's see. We can try to adjust that. Alright, I see what I need to do. Alright, let's leave it for now. So if you want this probability, then it's the probability to the left of your upper value minus the probability less than your lower value, leaving the wedge in between, and that probability would be the 18.99%. What's nice is this app can handle anything, so even if I asked what is the probability from 87 to 153, let's see, 117, it'll tell you the probability. Now this one's going to be more complicated if we use the chart to the left, and here's the breakdown of it. Oh, we have to set this as the same one. So what values? I should set it to where it's automatic. 87, 118. 87. 118. Alright, so here's how we would visualize it. So I'm going to take a picture of this so I can draw on top of it and clarify what I'm pointing at. And I do recommend that you guys subscribe and check for notifications, even though your class will be the first one Monday, Wednesday, and I will be hosting 4 classes a day. Alright, so when we're looking for this probability, let me get my pen tablet up and ready again. Yeah, we want red. No, that's too blue. So if we were to find the z-score associated with this, we could use the chart, and I'll show you that. So the z-score here would be 118 minus 100 over 15, which is 1 and 3 out of 15 is 1/5, so 0.2. So on our chart, we'd look up 1.2 and 0.0. Oh, I accidentally hit a button on my pen tab. 0, 0. And so if we looked up the probability associated with that, it would be 0.8849. So when we look up on the chart to the left, it'll give us the probability to the left. So that's what this graphic is illustrating right here. Then we want to subtract this piece right here. The problem is that a lot of times you're only given charts with positive values. So if you're given a chart with a negative z-score, because this would have a negative value of z, where's my pen again? There it is. Z would equal 87 minus 100 over 15, which is definitely a negative value. Then what's going to happen is you'd need a second chart. But if all I give you is the positive chart, then you would need to understand that by symmetry, if you're looking for, where's my pen again? Okay. If you're looking for this piece right here, flip it over. This by symmetry is equivalent to this graphic right here. And if you're given the value to the left and you want the value to the right, then whatever you're given over here, then this is 1 minus that value. So once you have the value in the tail, I need a bigger pen. I can't see where it's going. Let's see, customize it. Let's go and make it a large pen. Yeah, much easier to see. Once you have that value in the tail, then you have this value. And what you want is the difference between them. So it is kind of a hat trick. You have to switch it and flip it and understand symmetries. But if you have any kind of technology, like this application or a handheld calculator that has, a graphing calculator, or Excel, then you can do it quickly. All right, let me check chat. Yes, it will. I will leave this up. It will be posted. Alright, so we still got 15 minutes. Let's see what else I want to show you guys. Oh, and there's the context behind this, but the context when we do hypothesis testing is going to be where that comes into play. Right now we're just talking about the probability. So let's do another example, because we still haven't done enough to consider this a complete lesson. We've done, 2 primary examples. Alright, so let's look at this. I'm going to give you a hypothetical situation here, and then we will switch to the software, to the app here, and get the answer. I'm going to open myself a worksheet. Okay. Word is great because my pen tablet works with it. There we have a pen. Alright. So we have this rope that we use to climb rocks with, let's say. And the company says that the weight of this that it can handle is 350 pounds. So we are, let's say I'm much bigger than I already am, and that we want to know if it can handle, what is the likelihood it can handle a 375 pound load. Because just because I only weigh about 200, the backpack that I have to carry with me with my food and my tent and my everything else I need might weigh up to 175 pounds total. Just making an argument here. So they measured it, and they know they could be wrong up to 10. At least that's what they've specified the machine to be. So the question to you is, what is the probability that something heavier than that would work? What is the probability of this? So we will say, well, if this is normally distributed, because that is an assumption we will need. It's a lousy normal distribution, but it's kind of bell-shaped and wonky, a little bit symmetric. We know that 350 is in the center. Here is 375. And we know the pivot point is 10 points up. So what is the probability that it's further than that? Alright, the chart is going to give us to the left, but that's okay. If we know the probability to the left, then what we're looking for is 1 minus that probability. So we will convert this to a z-score. It becomes 375 minus 350 over 10. So we're asking, what is the likelihood that it can go 2.5 deviations above that? And so if we go to our app, that's not the app, that's the data. We would want to say, what is the likelihood that, well, let's go ahead and go to the breakdown. We know the mean was 350. That's just because it's so far away right now. The lower limit is going to be that 375. And the upper limit, well, we didn't specify, so we're just going to have to say keep going to a very large number. That's good enough. So here's what it's telling me to do. So if I want this, then I'll take the whole graph, right? That has an area of 1, minus the area to the left, and I will see that there's a 4.78% chance that this rope might hold more than that, 375 pounds. We could also figure out what is the maximum value likely by going backwards, but we'll do that another day. Alright, let's talk about the game plan for this semester. I think this format works. Let me know what you think in the chat. I need to know if it's helping, if it's not helping, what suggestions you have. And I also posted PowerPoints for you guys, lecture videos that I created before, and I will work on posting these apps. If you have any questions or concerns regarding the project, we can return to that now, but also I will set up the discussion board on Canvas so that you can post questions. If you have questions, if you can post them real quick, I'll give you a 20-second delay. Yes, it's going to be posted. Let's see. No other comments. We have 15 people watching. Very good. We have roll right here. Do you see it? Nice. And I invite you to come back to the 11 o'clock, because if you think of questions, you can always ask them. So if you have questions now, please type. And I'm going to get off the screen because it goes infinite. Alright, so what else is the next topic? Oh, let me show you the apps that I have. Actually, I'll try to show this to you next time. Any questions or concerns about the class? I have to wait for a delay because I'm asking the same questions before you hear them. I'll have to figure out how to turn off that delay. Alright, so once you hear my question about Do you have any questions? Please say yes or no in the chat so I know you heard me. Alright guys, we still have 10 minutes that I had intended to chat. What I can do is also set up some, like I said, discussion boards, anything else you need on Canvas. The way it's going to work is I'll put question banks on Canvas, and then I'll draw quizzes from those question banks. And then you'll have as many times as you want to try to get high score on those. And then when I write the test, you will be given 2 chances online to take that exam. And I'll take the average of the two, or I'll take the higher of the 2 scores. This will act as attendance. I will also make the journal online, so you'll use it instead of showing it to me. And the project you can either do individually on your own data set working with me, or we can do it as a group, and you just got to show me that you understand how to do the basics, descriptive statistics. And let's go and look a little bit of R. Okay, so for those of you who don't like R, this is optional. Let me show you how easy it is to use though. I'm going to go ahead and open the file that I was using to analyze the data. This is today. I was researching it earlier. Don't mind all of this. I'm doing it more advanced than you are at this point. So let me go ahead and show you the gist of this. You know what I'll do is show it to you one line at a time. So we're going to learn how to do machine learning. Right here this says, I'm going to call my data set D because I'm too lazy to write anything longer. What I want to put there, so this less than and dash is not read less than minus, it's read put there, or it's a command code in R. What I wanted to put there is what it reads in the CSV file that I've pointed to. So apparently this file is in my G drive in a folder called research, in a folder called virus, and it's called data, and it's a CSV file. Now the reason there's 2 backslashes is because R reads backslash as command to follow, and the command I want is the backslash. So we're going to tell it the command is go get the file. Then I'm going to say what are the names. Let's go ahead and run this. So I'm going to hit Control R. And notice in the background it said it went and put it there. So I'm going to ask it, what did you name the columns? And it'll tell me. So the data set I have is larger than the one you have. My data set I was able to find working with a client, latitude and longitude of these countries. So we're going to be able to do a little bit more analysis. But notice I still have the cases, the timeline, the total deaths, and so forth and so on. And so the dimensions of the data just tell me that there's 7,904 rows, which means the sample size, and I have 17 measures. So let me skip down a little bit. So if I wanted to draw me the table, this would probably be a little bit more complicated to use for that. We'll go over this another day. I think you're probably brain fried right now. You got plenty to think about. Let me check chat and see if there's any questions. Yes, definitely. For the question, will you post practice test? It'll be in the form of the quizzes. And so it'll be like your homework. What do I use? You can use Excel if you have an Apple, because I've used it on my I have an Apple laptop, and I've used it on my Apple as well. You can also use Google, Numbers or something like that. Numbers would work on your Apple. Good question. Alright guys, I think I'm going to sign off. email me or message me in the discussion board if you have any questions, concerns. And I'll be back in a half hour with the second class, same topics. Thanks, guys. Talk to you later. Bye.